This video is continuing with geometry vocabulary. We have a vocabulary word. We have our definition written. We're going to put examples and important information for the ones that need it. This word is angle. An angle is formed by two rays with the same endpoint. So if we just saw that with rays are one endpoint and then it goes off in one direction forever. So if we have two rays that share an endpoint, we have a ray going off in this direction. We can call this ray BA because we start with the endpoint. And then we can have another ray that shares the same endpoint of B going in a different direction. We'll name this ray BC. We have an angle. There are multiple ways you can name this angle. The first part is knowing that your B, your endpoint of both of your rays, is actually called your vertex. The vertex is the part that you need the most because that is part of how you name your angle. So to name the angle, you would use the symbol for the angle, angle. You would use your three letters. Your vertex needs to be in the middle. Just like in quadratics, your vertex is always in the middle of your parabola. Same thing holds true for angles. You would name this as angle ABC. So we would use the symbol angle ABC. Just like with rays, lines, line segments, points, planes, you need to put a symbol with it so that we know what we're dealing with. Because planes are also used with three letters, we have to put the symbol for the angle in front of the ABC to know that it is an angle. Another way to name this angle is we can say the letters backwards, but we still have to keep the angle B, part B, in the middle. So we can also name this angle CBA. Angle CBA. The important part is to make sure that your vertex is in the middle. Another way you can name this, and you can only name it this way if there is only one angle located here. This can be named as angle B because of your vertex. If there is something else connected to this angle, you have to use three letters. If this is the only angle that can be formed here, you can use one letter. You can also, if you have a number inside of the angle, not a degree, but if it's actually named like number 2, you can actually call this the angle 2. Angle 2. This is not a degree. This is not telling you how big the angle is, but this is just another way of naming them. If it's already given to you what that angle number is, you can use angle and then the number. The next word is skew lines. Skew lines are non-coplanar lines that are not parallel and do not intersect. So non-coplanar means that they actually do not lie on the same plane. So they won't be both on the paper, they won't both be on the floor. So you might have something on the floor and on the wall or on the ceiling. The best way to see this is if we were to draw a cube. So I'm going to draw a cube. I'm going to draw a square. Then I'm going to draw the top part of the square or the cube. I'm going to draw it down. I'm going to connect these corners. Now, this is a cube that you can only see the edges, but I want to make sure that we can see the parts that I'm going to do dotted lines to show that those actually exist. That's the back corner. Then we have the two parts that connect the bottom as well. This is to show the inside that you can't actually see, but just to show you the differences. So, to see skew lines on here, if you pick a line, you can pick any line you want. So I'm just going to pick this vertical line right here. I want to find a line that is skewed to this one, which means it cannot be parallel. So I cannot pick this line. I cannot pick this line. And I cannot pick this line. So all three of those lines are gone. It also cannot intersect. That means I cannot pick this line because it'll touch the orange, this line because it touches the orange, this line, or this line. So we only have a few that are left. I want it to be non-parallel and non-intersecting to this line right here. This line back here, the back bottom part, is not touching this orange, and it also is not going in the same direction because it's going horizontally instead of vertically. So this line is actually skew to my orange. This line, this top of the back, is also skew to the orange. This line right here, because it's not parallel to it, and it won't intersect it either because if I keep going, this line, it might look like it's going to intersect because of the way you draw it, but you got to remember this is three-dimensional. This line won't actually ever touch this line. So if you think about it as a room, this is a corner of the room, and this is on the other side of the room. So they won't ever touch. Same thing holds true with this line. This line also will never touch the orange. So all four of those that I just mentioned, so we have this one up top, this one that is already highlighted, this line right here, and this line right here are all skew to this one right here. So we actually have 4 lines that are skew to this single line that I drew. So we can name any 4 of them. So skew lines, again, never intersect, and they also are not parallel. So that's one of the reasons why they are non-coplanar. The next word is segment addition postulate. Again, postulate is an obvious fact. It's an already stated fact. It's something that you do not have to prove. It's an accepted statement of fact. Segment addition. Segment, we're going to be dealing with segments, and we're going to be dealing with adding. So if we have 3 points, which are A, B, and C, are collinear. That means we're going to have a line, and B is between A and C. That means that we're going to have A and then C, and B is going to be in between them. Now, since it's segment, we're going to have segment AC. So we'll have segment AC. And B is in between them. So I can put B anywhere I want to in between them. I just know that B is in between them. If we have segment and another segment, then this length plus this length of BC is equal to the entire length of AC. And if you think about it, if you have a pin plus another pin, you have 2 pins, so we just add them together. So let's say that length AB, notice that there's a segment symbol on top of this because this is talking about the distance of it. If I say that segment AB is equal to 2, the distance is equal to 2, and the distance between B to C is 3. The question is asking, how long does it take to get from A to C? So if you take 2 steps to get to B, and then 3 more steps to get to C, you take a total of 5 steps. So we can say that the length of AC is equal to 5, because all you do is just add them. If I know how far I go from A to B, and I know how far it takes to get from A to C, I could say that AC minus AB is equal to BC. So I could solve this one even if I don't have one of the lengths. If I have 2 of the lengths, I can find the third. We're going to do the same thing with angle addition postulate. It's very similar. It's just going to be in angles. So we're going to have angles. We're going to add them. And again, a postulate is an accepted statement of fact. It says if point Z is in the interior, that's inside, of angle WXY, then it says the measure of angle WXZ. The M is telling you that it's talking about the amount of it, the degree. Just like up here with the segments, I did not put the segment symbol on it because I'm talking about distance. The same thing happens here with the M angle, so this is called the measure of angle WXZ. So if we draw this out, we have WXY is our actual angle. So I'll draw out an angle. So again, we have 3 points. An angle is made by 2 rays. WXY tells us that X is our vertex. So I can have WX and then XY, ray XW, and ray XY. And it says that Z is in the interior. That means I can have Z over here because it's inside of it. That means I can actually draw a ray from X to Z. What this states is that to form this entire angle, we have this little angle right here of WXZ. We have the angle of ZXY. If we put them together, we'll get the entire angle, just like with the segments. So if I were to have, let's say that the measure of angle WXZ is equal to 28 degrees. And the measure of angle ZXY is equal to a measure of 32 degrees. We could say that 28, we could actually add these to get the entire thing. So we'd have 28 plus 32 is equal to 60. So we could say that the measure of angle WXY is equal to 60. Because we can add the individual parts to make the whole. Just like everything is made up of individual parts, and you combine them to make the whole. The next word is congruent. This is a word you might have heard multiple times. Congruent means to be the same shape and size. So if we see that symbol congruent, it's that the equals with the squiggle on top of it. The equals part is because it's the same size. The squiggle on top, this is a similarity symbol. This is because they're the same shape. This is why we have both of these together. A congruent has to have the two parts here for equal, and then the squiggle on top. Now, there are two different things that we can have congruent. We can have the angles and the segments themselves. So if I draw out I'm just going to draw a triangle just to show you. So draw a triangle. To show that the line segments themselves, the parts of the triangle, are congruent, if I have a line right here, the segment is congruent to another segment, I use tick marks to show that the segments are congruent. If I have one tick mark on this segment and one tick mark on this segment, that means that these two segments are congruent. If I have 1 and 2 on this one, those are not congruent. The amount of tick marks matter. So I can say that these show that segments are congruent. The tick marks show that segments are congruent. To show that the angles are congruent, instead of just having to put the amount inside of it, we use arcs. So we can say the same thing if I have one arc on this angle and I have one arc on this angle. That means that I have the same amount of arcs on both angles. These angles are congruent. That's what that represents. The angles are congruent. Angle is congruent. We use the arcs for the angles. Now this actually, whenever you have inside of one triangle, because this is in one triangle, if I have a congruent tick mark and then the same congruent tick mark, across from those congruent tick marks, I have to have congruent arcs as well. But that only happens inside of a single triangle. So if I have one tick mark, 2 tick marks, 3 tick marks, I would have 1 arc, 2 arcs, 3 arcs. I would have to have the same amount of arcs as I do tick marks, as long as I'm dealing with the same triangle. So this is the symbols we use for congruency for sides and for angles. The next word is equal. This is something you've seen multiple times. It means of the same measure, quantity, amount, number, or value as a number. We say that numbers are equal and things are congruent. So this is a symbol, this is a thing, this is a side, and this is an angle, this is a thing. That's why these are congruent. But numbers, distances, the measures, these are equal. I do not say that angle WXY is congruent to 60 degrees, because that's a number. We say that things are congruent, but numbers are equal. We use the symbol equal. The next word is bisect. Bisect means to divide into two equal or congruent parts. Depends on what you're dealing with, if you're dealing with numbers or things. Bisect can be used for both segments and angles. So if we have a segment bisector means to cut it in half. So if we have a segment, this is a segment, and if I want to cut it in half, I would find the exact middle, and I could say that these two segments are congruent to each other. Now the symbol for that again is that tick mark. We have one tick mark in each of these, and this is a segment bisector. Segment bisector. Because it's cutting the segment into half. You cannot cut a line in half because lines go on forever. That's why we have to talk about segments, because segments actually stop and we can find the middle of that segment. You can also have, for bisect, you can have an angle bisector. So if I have an angle, just a big angle, to cut this in half, I need to have a ray going through the middle of our angle. And again, to show that this is a segment bisector, to cut in half of two congruent parts, I use the arcs to show congruent. So if I have one arc here, and I have one arc here, they do not have to be in the same location. The amount of arcs is what matters. So since these both have one arc each, these two angles are congruent. Therefore, this ray is a segment bisector, or an angle bisector, excuse me. This ray is an angle bisector. Angle bisector. So bisect can be used for both segments and angles.